Hi, Mr. Pepperell here, and in this video we're going to be talking about alternating current. So when we've been talking about electric circuits up until now, we've pretty much thought about them like this, okay? This is a simple circuit which could be a torch, you've got a switch and a bulb there. Okay, and when you switch it on, the electrons start to move. Okay, they come from the battery up here. This is the negative terminal, and this is the positive terminal of the battery. Okay, so the electrons start to move. They start to come out from the negative and they start to flow around the circuit, and this flow of charge transfers energy from the battery up here down to the bulb there, and the flow of electrons is always in one direction. Okay, it's coming out of the negative terminal and they're flowing towards the positive terminal, going in this direction. So the current is always flowing in this direction round the circuit. Okay, it's always in the same direction, so we refer to this current as direct current, and we can abbreviate that to DC. So that's what we've been thinking about up until now. However, this isn't always the case, and if we switch on any device that's actually connected to the mains electricity, okay, the main supply which you've got at home, the electrons don't just move in one direction, so we haven't got direct current like we've got here, with the electrons constantly just moving in the same direction all the time. At home, the direction of the current is actually constantly changing. First it's going one way, then it's going the other way, and it swaps from this way to that way, to and fro, back and forth. The direction of the current is always changing. Okay, it goes one way and then the other. The direction keeps alternating. That's what we call it. First it's going in this direction, then it's going in an alternative direction that way. So we've actually got in this case what we call an alternating current, or we can abbreviate that to AC. So we've got the current constantly changing direction. It's going this way, then it swaps and goes that way, then it swaps and goes this way, and it swaps and goes this way. It's constantly swapping back and forth. It's cycling back and forth. This is actually what we call one cycle here. That is the bit that we call one cycle across there. Okay, from this peak up here goes one way, it goes back the other way, back to where it started. That's one cycle there. Okay, so the current is continually cycling one way or the other, and the number of cycles it actually goes through every second is called the frequency, much like number of waves per second when we talked about waves before. So number of cycles per second is the frequency, and the same as waves, we measure frequency in hertz, denoted by the Hz there. That's the units, hertz. Okay, and mains electricity in the UK, and this is a figure you just actually have to remember. Okay, you will get asked this in the exam. Mains electricity in the UK goes through this cycle here 50 times every second. Okay, so you get 50 of these cycles, the one way then back the other way cycles every second. So UK mains electricity has got a frequency of 50 hertz, and that is a number that you just need to remember. Okay, and that's what makes your light bulb work. If you had a frequency of lower than 50 hertz, say it was only 10 hertz, okay, so this current was changing direction only 10 times a second, all right, your light bulb would flicker. You'd notice it changing direction, but up at 50 hertz, that's enough for your light bulb actually to work properly. Okay, so how are we getting this alternating current in our mains electricity supply? Okay, well, every main circuit in the UK has got two wires in it. It's firstly got this, well, in this picture here, we've got a reddy browny wire, which is the live wire, and we've also got this blue wire, which is our neutral wire. Okay, now you need two wires, and you'll see why it is in a minute. Okay, because the main supply, what it actually does is it creates an alternating potential difference between these two wires. Okay, now first thing is, don't worry about how we do this at the moment. Don't worry about how that potential difference is created between the two wires. We're going to find that out, just not yet. So don't worry about it for the moment. Just accept the fact that between these two wires there is a potential difference which has been made. Okay. Why do we need to create this potential difference to them? Because the potential difference makes the current flow. Think about a hose pipe full of water. If I hold one end much higher up in the air, the water is going to flow down to the other end. We've got a difference in height, so the water flows. In electricity, if you've got a potential difference between two things, a current will flow between them. Okay, so if we have a little look at our trace a second, and on my trace here I've got my potential of my blue neutral wire, shown by this blue line here, and the potential of my reddy live wire, shown by this trace here. Okay, so during one half of these cycles that we've talked about before, okay, the potential difference between the live and the neutral wires is 325 volts. Why is it? Well, if we look at the neutral wire, basically the potential of that one is down here practically zero. The potential of the live wire is up here at positive 325 volts, which means we've got a potential difference. The difference between the two is 325 volts, and that difference between the two wires makes the current flow. Okay, this is actually what we refer to as the peak voltage. Up here, 325, that's as high as it goes. That's what we call the peak voltage. So in the UK, our peak voltage is 325 volts. Now, in the other half of the cycle, coming down here, we can see that this time we've got a potential in the live wire of negative 325. Neutral wire is still zero, but the live wire is negative 325. Well, what that means is, again, there's a potential difference between this potential and this potential of 325 volts. Okay, it's just because this time, you know, it's basically, to use our hose pipe model again, this time I've just held the other end of the hose pipe up. One end of the hose pipe is still much higher than the other end, it's just the other end this time, so the water flows in the other direction, or in the case of electricity, it makes the current flow the other way. So because this potential difference is constantly changing from plus 325 down to minus 325 and back again, the current first flows one way and then back the other way, and what we actually get is our alternating current being produced. Okay, so we get an alternating current because of the alternating potential difference. Now, this neutral wire here is actually what we call earthed at your local electricity substation, which you may or may not have seen in your local area. Looks a little bit like that. Okay, and what we say is the potential difference between this earthed neutral wire and this live wire, it's got a special name. We either call it the potential or the voltage of the live wire. So the potential difference, the 325, is known as the potential or voltage of the live wire. So you might feel like there's been quite a lot of info in this video, but let's have a little summary here and think about what we actually need to remember from all this. Well, firstly, we need to be able to state the difference between direct current and alternating current. Okay, so basically direct current, or DC, is a current flowing in one direction. Alternating current means there's two different alternative directions it can flow in. So alternating current, or AC, the current changes direction. That's the first thing. Secondly, we need to know how many times does it change direction. We need to know the frequency of UK mains electricity. Okay, that frequency is 50 hertz. That means that this change of direction goes through 50 cycles every second. Okay, next we need to know, well, where's this alternating current coming from? Well, the AC current in UK mains electricity flows due to an alternating potential difference between the live and the neutral wires. That was the brownie ready and the blue wires. The potential difference between those two makes the current flow. Okay, finally, if we just have one last little look at this plot a second, okay, if we took all these voltages, every single number, if we read all the numbers off this red wavy line going up and down here, we took the peak voltages, the ones that are close to the line there, and we averaged them all out. If we took all the potential difference values of this plot, we averaged them all, what we'd find is that UK mains voltage on average has got a voltage of 230 volts. Okay, so the actual work that could be done by the AC supply is 230 volts. We call that the mains voltage. That is another number that you just need to remember. Okay, so know the difference between these two, know the frequency of UK mains, know why that alternating current flows, and know what the mains voltage is.
So that is what we need to know about alternating current. Any problems with that, email me or tweet me at Mr_Pepperell and I'll get back to you ASAP. Thanks for stopping by.